So I'm going to do 10.2. So 10.1 is easy and the problems are also simple. You can do it yourself. The first is problem 7. Find the equation of the tangent to the curve at the given point by two methods. The curve is given to us. So we have to find the equation of tangent to this curve at this given point 1, 3. So as you can see, both x and y are function of t. And we have to do it by two methods. So first method is without eliminating the parameter. That's the question. That's what we are trying to do. We have to find the equation of tangent first without eliminating t. So to find the equation, what we need is slope, which is dy over dx. Since both x and y are function of t, and then we have to calculate at given point. Now let's take the derivative. Dy over dt is 2t. And dx over dt is 1 over t. So dy over dx becomes two t cube. But we have to find it at the point 3, 1. So if you observe this point implies x is 3, y is 1. And if we look at the equations for y and x, so y is t squared plus 2. Oh, I made a typo here. This is actually 1, 3, not 3, 1. Right, so this means x is 1, y is 3. So if you look at the equation, y will be 3 when t square is 1 and x will be 1 when ln t is 0. So this means your t is 1. So this is very important that from given x and y, from their equations, you are able to figure out what t should be. So when t is 1, ln 1 is 0, so x is 1, t square is 1, so y is 3. So that's the first thing you should be able to do. For any given point, look at the equations and deduce the value of t. So now we compute it at t equals 1. So the slope is and the equation becomes y minus the given point equals slope times x minus the given point. So this is equation of tangent by the method of without eliminating t. Now there's another method. First eliminating the parameter. So here now we first have to get rid of t and then find the equation of tangent. And we should get the same answer. So answer should be same as part A because the tangent is same. So this should be the answer, but by a different method. So first eliminating t. So let's write here what x and y are. So we have to eliminate t. So this means or t equals exponential x minus 1. So now we have t in terms of x. Now we substitute it in the equation for y. And when we square this exponential, okay, so this is y. Now to find the equation, we need to find slope. at given point. So dy by dx, chain rule. So when x is 1, the 2 times. So we are getting the same slope. So it means we are doing things correctly. So you can see the slope here is also 2, and we're also getting 2. So the equation then becomes which is same as what we expected. So the two different methods have given us the same answer of equation of tangent. You can see both answers are same. So this is one type of problem in 10.2. Let's do a different type. Let's do problem 11. We have to find dy over dx and d square y over dx square. And for which values of t is the curve concave upward? The curve is given to us as and the question is find dy over dx, d square y over dx square, and for what values of t is the curve concave upward. So the first step is same. Let's compute what is dx over dt. It is 2t. And dy over dt is 2t plus 1. So dy over dx becomes which is now this is dy over dx. But now next step is we have to find the second derivative. So if you observe what is second derivative, this is d over dx of dy over dx. But this is a function of t, dy over dx is a function of t. So we write it as d dt. So you see it's just like multiplying dividing by dt. So this dx moves here. Now we can take this thing in the denominator, which gives us So the second derivative is given by this formula. d by dt of dy over dx divided by dx over dt. So if you remember this, you can use it directly, or it's just one step to get it. So let's compute. So we know what is dy over dx, it's this term. Let's compute its derivative, and then we know what is dx over dt, which is 2t. Derivative of 1 is 0, and derivative of 1 over 2t is 2t square. Therefore, divided by dx over dt, right? Because we have 2t in the denominator, so this in denominator multiplies by the denominator of dy of the numerator. Now we have to determine when this curve is concave upward. So concave up means the second derivative is positive, but second derivative has a negative in front of it and a t cube. So this means and this is true when t is negative. So because when t is negative, t cube will be negative, and then this negative will give us positive. So this is again an important formula-based problem. If you remember the simple derivative roots, you should be able to do it. Now let's move on to something else. Problem 41. The question is, find the exact length of the curve. So the curve given to us is So this curve is given to us and we have to find the exact length in this interval. So exact length is the arc length. You integrate from t equals 0 to 1. So it's the same arc length of chapter 8. But here, since we have a parameter, so the arc length is given by so this means your L is, in this case, t from 0 to 1. Now let's compute what are dx over dt and dy over dt. And we have to square and add them. So dx over dt is 60 dy over dt 60 square. So the expression for length becomes so squaring and adding them. So we have 36 t square plus 36 t4. I can factor out 36 t square. Now when this 36 t square comes out of the radical, it becomes 6t. Right. So this 6t when goes inside, you have to square it, so it becomes 36t square. Because this factor is the square root of 36t square, which is 6t. Now this is a simple u substitution. So if you make u as 1 plus t square, du over 2 will be t dt. Now here you have to be careful because with bounds, so here you should be bounds, you should put bounds of u. So let's first write it without any bounds. Now when t is 0, u is 1. And when t is 1, u is 2. So what I'm writing here, u from 1 to 2. Right? Because when t is 0, u is 1. And when t is 1, u is 2. By this time, you know this. So this is your final answer, but you can rewrite it in any form you want. This is same as, and which is same as, and this all are positive. So arc length will always be positive. Because 2 root 2 is greater than 1. And let's do one more problem which is similar to chapter 8.1 but with this new parameters. This problem 61. Now 61 is find the exact area of surface obtained by rotating the given curve about x-axis. So the curve given to us is x equals t cube y equals t square t is from 0 to 1 and we are rotating about x-axis. So remember from chapter 8 when rotation is about x-axis, the formula for area is 2 pi and here t is from 0 to 1. So y is also a function of t, ds is also a function of t. So area becomes formula for this arc length is same as the last problem. Now let's compute what is dx over dt and dy over dt. Easy to see. So now we have to square them and add. We can factor out a t square. Now, similar to the last problem, when this t square has a radical on top of it. So when this comes out, it will change as t. So it will become t. So this is now t cube. Now we have t cube outside. We already had t square, and then this radical of this t square gave us t. So we have t cube, and inside is 9t squared plus 4. And how to do this antiderivative? So this is again a good example of u sub, which you should know by now. So u is du is so du over 18 gives us t dt, but we have t cube, so it means we need an expression for t square in terms of u, which this equation will give us. So t square is u minus 4 over 9. So now we substitute everything. So for t dt, we substitute du over 18. For 9t squared plus 4, we substitute u. And for the remainder t squared, we substitute u minus 4. Let's leave the bounds for now. Let's first do the substitution. So we have 1 over 18 here. Then we have u minus 4 over 9. Now if you want to put the bounds, those should be the bounds for u. So when t is 0, u is 4. And when t is 1, u is 13. This is U, not 4. It looks like 4. Now I can cancel this 2 with 9 here. With simple power rule. Now this is some calculation you can do using your calculator, or you can avoid it. It's up to you. This is the same thing I have written again, but this 2 over 5, I brought it in front and multiply this 4 and 2. So substituted 13 in both the terms, and then subtracted by substituting 4 in both the terms. Okay. Now again, if you have calculator, you can do it faster, but let me just finish it. So here I'm just factoring out this vector. Now this is easy to see. 2 over 5, 4, square root of 4 is 2, 2 to the 5 is 32. Square root of 4 is 2, and this minus becomes plus, minus, minus, plus, right? Negative, negative, positive. Eight times 8 is 64. 32 times 2 is 64. So after taking the common denominator, which is 15, we would get so this is the final answer. So you can finish the steps in between using the calculator, but this is the final answer, which is positive. But the important part is to set up the antiderivative for the area and do things correctly, and then there is some lot of algebra, and then finally you will get this answer. So this is 247, radical 13 plus 64. Okay.